Alrighty everyone, this is our 3.6 video for properties of logarithms. So you should already know a little bit about logarithms and have done the introduction to logarithms as you are watching this video. So you should kind of recognize that logarithms and exponentials are inverse functions, and you can use that idea to convert between exponential and logarithmic form. We're going to use that those same ideas today as we work on the learning target. I can use the properties of logarithms to simplify logarithmic expressions. So let's take a look here. Go ahead and open up your notes. So we're going to focus in on these three properties of logarithms: the product property, the quotient property, and the power property. We're going to take a look at both the exponent property, because these are named the same things, the product, the quotient, and the power properties for exponents, and we're going to see how they relate to the logarithmic properties. And then we're going to work to expand or simplify expressions using these properties. So for our product property, in the exponent form, the product property says that if you are multiplying the same base, something like x to the m times x to the n, what you can do, as long as it's the same base, you can add the exponent. So x to the m times x to the n equals x to the m plus n. So as an example, x to the second power times x to the third power, same base here. We can add those exponents. We would get x to the fifth power. For logarithms, there's a similar product property using that addition. So if we see a single logarithm where we are multiplying inside, like m times n, we can expand that and split apart. So when we're expanding, we're splitting apart that logarithm into more than one logarithm. So we can expand that to be the log of m plus the log of n. So if we see something as an example, like the log of 3x, we know that there's invisible multiplication. There's understood multiplication between the 3 and the x. So we can expand that to be the log of 3 plus the log of x. So that's our product property. It's this idea that when we're multiplying inside the logarithm, we can expand that out to using addition. And if we see multiple logarithms with the same base being added, we can condense that down using multiplication. So we can move in both directions here. Our quotient property, we're thinking division, right? So product, if I go back, product is multiplication, quotient is division. And so the exponent property for quotient property is that if you are dividing variables, say x to the m divided by x to the n power, as long as they have the same base, you can simplify that to be x to the m minus n power. So in this case, we are subtracting the exponents. As an example here, we have x to the 7th power divided by x to the 3rd power. Again, same base. So we can say that, that's just going to be x to the 7 minus 3rd power, which is going to be x to the 4th power. Again, our logarithmic property is very similar. If we see division inside of our logarithm, like m divided by n, we can expand that logarithm out to be the log of m, the log of our numerator, minus the log of n, the log of our denominator. So the order here does matter. So let's write that down. The order matters because we know with subtraction is not commutative. which means the order does matter. 3 minus 5 is not the same as 5 minus 3. So we just need to be careful with our order. Looking at this example here, so in this case, I'm seeing subtraction, and I'm seeing two logarithms with the same base. I'm seeing the natural logarithm. So it's the natural logarithm of 5 minus the natural logarithm of 3. So in this case, I can condense this down to a single logarithm by moving in this direction, where I'm going from that property on the right to the property on the left. So going from the subtraction to the division here. And I know that that's going to be, my base stays the same. So the natural logarithm of 5 divided by 3. And if I was able to simplify that, I would, because we always want to simplify anything inside of our logarithm. So just to go back for a moment, for this first example up here, as we were moving from a single logarithm to multiple logarithms, in that case, we were expanding our logarithm. And in our second example, we went from multiple logarithms down to a single logarithm, and that was condensing our logarithms. So we can use any of these properties to move in either direction, either to expand it or to condense it. Let's look at our last property here. That is our power property. And when we're thinking our power property, we are thinking of exponents. So for our exponent property, for the power property, if we have x to the m to the nth power, we are going to multiply the exponent. So that's x to the m times n. So for example, here we have x squared to the 4th power. Because this is an exponent to another power, we're going to multiply those exponents. So that's x to the 2 times 4 power, which is going to simplify out to x to the 8th power. Now for our logarithmic property, if we have the log of some value to an exponent, we can actually take that exponent, and as we are expanding, we can move that exponent in front to be n times the log of m. So that exponent becomes the coefficient of the logarithm. So notice in this case, in this example, we have the log of 3, log base 3, of x squared. So I'm seeing this exponent inside my logarithm. So I'm going to take that and make it a coefficient of the logarithm. So we will have 2 log base 3, because that base stays the same, of x. So in this case, again, we are moving from the left side to the right side. We are expanding that logarithm. So we are expanding our logarithm there. So from that, we can either expand or condense logarithmic expressions using these properties. And we're going to want to do that when we have a more complicated expression that we want to simplify. And sometimes we need to do this in order to be able to solve equations that involve logarithms. And expanding or condensing, moving in one way or the other, helps us to be able to more easily solve the logarithmic equation. Now, the key thing here, in order to use these properties, any logarithms you're using must have the same base. This does not work. You cannot condense logarithms that do not have the same base. So we have to have the same base to use these properties. Let's look at some examples over on the right side here using these properties. So our first example is asking us to rewrite the logarithmic expression as a single logarithm with the same base. So when it's asking us for a single logarithm, it is asking us to condense this current expression. So I'm going to check here first that we have the same base. We do. We have 2 and 2. I'm noticing here that we are adding these two logarithms, and my logarithmic property with addition is our product property. So this is what I'm going to use. So I'm going to use our product property here. And then by definition of the product property, if I see addition, I can take the 4 and the 5 here and multiply them in a single logarithm. So that's going to be giving me log base 2 of 4 times 5, which if I simplify that is log base 2 of 20, because 4 times 5 is 20. So that would be my simplified expression. For example number 2, this is asking me to expand this logarithmic expression. What that means is we want to expand this out until we only have one number or a single variable, if we had variables here, in each logarithm. So we want to expand it as far as we possibly can. So in this case, I'm noticing that I see division. We're going to use the quotient property. And I know that the quotient property was here because I see that division. So we're going to expand this into subtraction. So what I would see, if I have the log base 7, we know that that's a base 10, log of 7 over 9. We're going to take the log of the numerator, so the log of 7, minus the log of the denominator, log of 9. And that is, if I'm looking here, I just have a 7 and I have a 9. I don't need to expand that any further. I have a single value, a single number in each of those those logarithms. Looking at the next example, expand again the logarithmic expression. I'm seeing the natural log of x to the 5th power. I'm noticing here that I have an exponent inside of my logarithm, so I'm going to use my power property. So I'm going to take that 5, whoosh, pull it out front using this power property here. So we're just taking that exponent and it becomes our coefficient. So that's going to be 5 times the natural log of x. So for each of those, we only needed to use one property, but where that's not always going to be the case, sometimes we're going to have to use multiple properties. So this is kind of one of my favorite types of concepts to work with, because it kind of feels like a puzzle. Figuring out which properties do I need to use, in which order am I going to need to use them. I really enjoy problems like these because I just get to, it feels like a puzzle and I love it. So looking at these next two examples, we're going to be looking at using multiple properties here. So as I look at example number 4, rewrite the logarithmic expression as a single logarithm. I'm going to need to condense this as far as I can with the same base. So I'm noticing a few things here as I'm first looking at this. I'm noticing that I have some addition between logarithms. So that tells me I'm going to need to use my product property. I'm also noticing that I have a coefficient in front of this first logarithm, which tells me I'm going to need to use my power property. So what I'm going to do first is use my power property to put that exponent back inside. That would give me the log of 5 squared. And then I still have my plus the log of 4 here. I haven't done anything with that yet. And I'm going to actually multiply out or simplify out, evaluate that 5 squared. So that's going to be the log of 25 plus the log of 4. And now I can still do a little bit more here. I still have 2 different logarithms. And so now I need to use that product property. And I know that the product property tells me that I can simplify this to a single logarithm where I multiply the 25 times the 4, which is just the log of 100. So I used both the product and the power property to be able to simplify that expression. Looking at our next example, our last example here, rewrite the logarithmic expression as a single logarithm again. Once again, I am going to condense this with the same base. There's a lot happening in this one, isn't there? I'm seeing addition, which is going to be my product property. I am seeing subtraction, which is going to be my quotient property. And I am also seeing a coefficient here of 2, which is going to be my power property. So in this case, we're going to use all 3 properties. So let's think about what makes sense in terms of the order. So as we're looking at this, it makes sense to me to move that 2 back inside first, because it's only on a single logarithm. So I'm going to do that first. We're going to take the 2, use my power property to move that back inside. So we'll have the log base 3 of 7 plus the log base 3 of 4 minus the log base 3 of 5 squared. Or if you're doing kind of multiple steps at the same time, we can also just immediately say, oh, well, we know that 5 squared is 25. From here, I still need to do both my product property and my quotient property. And at this point, we're going to move from the left to the right. So the first thing we're going to do is that product property. So log base 3, and then multiply together, that's 7 times 4, which would give us 28. And then the product property here divided by, my bad. Let's just see, I was getting ahead of myself a little bit, and I almost made a pretty big mistake. So log base 3 of 25. Let's do that multiplication. So that would be the log base 3 of 28 minus the log base 3 of 25. Now let's do our quotient because of that subtraction. And we're going to have log base 3 of 28 divided by 25. We would want to reduce that fraction if we could, but we can't. So that is going to be our final answer.